Good afternoon, class. We are looking at chapter 3 derivatives here, section 3.5, the chain rule, and this is the second part. A bacterial colony is estimated to have a population of P of t equals 24t plus 10 over t squared plus 1 million t hours after the introduction of a toxin. What is the population after 1 hour? This is elementary algebra. Simply put, plug in number 1. So we get 24 times 1 plus 10 over 1 squared plus 1. 24 times 1 is 24. Plus 10 is 34. 1 squared is 1. Plus 1 is 2. And we get 17 million bacteria. At what rate is the population changing 1 hour after the toxin is introduced? The moment we see rate and 1 point in time, that means differentiation. So we want P prime of t. And P of t is a fraction is using the quotient rule. So we are going to write f over g. And f prime g minus g prime f over g squared. This is the formula we are going to use. So f prime is 24 times g, which is the denominator t squared plus 1, minus g prime, the bottom gives us 2t, times g, which is the top 24t plus 10, over g squared, the bottom squared. And this is the extent of calculus. So we are going to distribute. We get 24t squared plus 24 minus 48t squared minus 20t. These two add up to negative 24t squared. We write the rest of them. And for 1 hour, we are going to plug in. So negative 24 times 1 squared minus 20 times 1 plus 24 over 1 squared plus 1 quantity squared. Plug in. This is 1. You get negative 24 minus 20 plus 24. This is 1. With 1 is 2. Squared is 4. Negative 20 over 4, or negative 5 million bacteria per hour. Please understand that P prime is dP dt. The units of the numerator over the units of the denominator. And it means the population of bacteria is decreasing at the rate of 5 million bacteria per hour, 1 hour after the toxin is introduced. Please understand, when you have a negative, when you want to do the writing, you don't use the negative, rather you write decreasing. If it's positive, you say increasing. Example 3. Observations show that the length in millimeters from nose to tail of a Siberian tiger can be estimated by the function L equals 0.25 W to the power of 2.6, where W is the weight of the tiger in kilograms. Furthermore, a young tiger's weight can be estimated in terms of its age t in days by the function W equals 3 plus 0.21 t. How long is a tiger when it's 100 days old? There are two ways to handle this question. You can find the composite function and make L a function of t, because L is a function of W, W is a function of t. or just the way it is, we can do the job. I'm going to look at them both ways. So first and foremost, 100 days, replace the t with 100. This has two decimals, this has two zeros. 1 0 cancels out one decimal, so two zeros cancels out two, and the answer is 21. When you multiply these two plus 3, we get 24 kilograms. So the weight is 24 kilograms after 100 days. But we are interested in the length. So you are going to plug in to this equation, and L of 24 becomes 0.25 times 24 to the power of 2.6. Put it into a calculator, and you get 969.369 millimeters. Now, I just want to remind you that as you know, in the metric system, 1 meter is 100 centimeters. Also 1,000 millimeters. And this is close to 1 meter. It's not quite that, but it's close. At what rate is the length increasing? When it is 100 days old. So you want the L dt. So according to Leibniz's notation, dy dt is dy du dt. And the intermediate variable is u. So we want dl dt. I'm going to write it in the same format. The intermediate variable over here is u. However, here, as we want to go from L to T, in between is W, so it's dW. dL dW, dW dt. So what is dL dW? You are going to differentiate this with respect to W using the power rule. 0.25 remains. Nx to the power of n minus 1, n is 2.6. Instead of x, we have W to the power of 2.6 minus 1, or 1.6. So again, 0.25 remains. The exponent becomes the coefficient. W to the power of, subtract 1 from the exponent. So that's dl dw. What is dw dt? Simply 0.21. Now the product of the three numbers, 0.25, 2.6, and 0.21, gives us 0.1365. W to the power of 1.6. So this is not changing. You have two choices. You can replace the W with 3 plus 0.21t and then plug in t equals 100. Or notice in the previous step, we know what is the weight when the tiger is 100 days old. 24, replace it. 0.1365 times 24 to the power of 1.6. Put it into a calculator. 22.0532 millimeters per day. The units of the length over the units of the time. The second method is to find the composite function. L is 0.25 times W, replace it with 3.21t to the power of 2.6. Now this is the composite function we found. And so if we want L of 100, plug in 100 here. So 0.25 times the parenthesis 3 plus 0.21 times t, which is 100 to the power of 2.6. You put it into a calculator and it gives you the answer, which is the same as what we got here. And now the LDT, or L prime of t, 0.25 remains. Now we're going to use the extended power rule on this parentheses, times 2.6, times the parentheses to the power of 2.6 minus 1, or 1.6, times the derivative of the inside, which is 0.21. So again, 0.25 remains, times the exponent 2.6, the parentheses to the power of 2.6 minus 1 makes it 1.6 times the derivative of the inside by the chain rule, which is 0.21. Again, we multiply these three numbers and we get the same. And notice these two are identical if you replace the W with 3 plus 0.21t as it was mentioned before. And now replace the t with 100 and you must get the same answer as here. And again, it's positive. It means increasing because they most of the time use changing rather than increasing, and you would say it's increasing because it's positive. So that means the length of the tiger is increasing at a rate of 22.0532 millimeters per day when it's 100 days old. That's the meaning. The amount of glass recycled in a community is G of P equals square root of 0.5 P squared plus 7 tons, where P is the population in thousands. It is estimated that 10 years from now, the population of the community will be P of T equals 4.4 plus 0.1 T squared thousands. How many tons of glass are expected to be recycled 4 years from now? The reason we look at this, and I did that for the previous example, from both points of view, from a composite function point of view and Leibniz's notation, because sometimes one is easier than the other. In this case, I'm going to go with the Leibniz's notation, and that's easier. So first and foremost, the first part is elementary algebra. We are going to plug in 4. (16 times 0.1 is 1.6. With 4.4 becomes 6,000 people. And if you replace the P here with 6,000, with 6, you get 36 times 0.5, which is 18, plus 7, which is 25. The square root is 5 tons of glass. Elementary algebra. Find the rate at which the amount of glass recycled is changing with respect to time 4 years from now. And now you differentiate because you see the rate at one point in time and you want dg dt. Again, I'm going to go with the Leibniz's notation and I'm going to write dg dt. And I say that, okay, from g to t, the intermediate variable is p, so we need dp. As it's the case here, dy dt, the intermediate variable was u. So dg dp, you are going to differentiate this, and to do so, we are going to rewrite this in a format that extended power rule can be used. So the same thing to the power of 1/2. And now the derivative of this piece follows this. 1/2 sits in front, the same thing to the power of negative 1/2 times the derivative of the inside 0.5 times 2p makes it p. So to recap, we are differentiating this, everybody. That's dg dp. So first you have the 1/2. Then you have the same thing to the power of 1/2 minus 1 or negative 1/2. Then the derivative of the inside is 0.5 times 2p. 0.5 times 2p is p. Now what is dp dt? Just look at this one. It's 0.1 times 2, 0.2 t to the power of 1. So 0.2 t. And from the previous step, p is 6, t is 4, we can plug in. Before we plug in, let's simplify. You have a fraction bar. In the numerator, you have 1. You have a p. You have 0.2t. So you have 0.2 pt. In the numerator, in the denominator, you have 2. This one has exponent negative 1/2. Take it down. The exponent positive 1/2, which becomes a square root. Again, p is 6, t is 4. We are going to replace the p and t accordingly. And I hope you recognize right here, if I replace the p with 6, I get the same answer as 5 here. So this one is 2 times 5. Again, plug in 6, 36, half of it is 18 and 7. 25 comes out as 5.2 times p, which is 6, t, which is 4. The numerator, 4.8 divided by 10, or 0.48. dg dt, units of the g over the units of the t, tons of glass per year, which means 4 years from now, the amount of glass recycled is increasing at a rate of 0.48 tons of glass per year.